Okay, so, okay. If, real quick, everybody's, this is a line, it tells me it's a line from between those 2 points. If I just ask you to figure out the equation of the line, that's all I ask you. Which is really what this is asking, but it wants it parametrically. If I just said, what's the equation of the line that goes from here to here? I gotta make sure you know what to do in that case, because otherwise you're not gonna understand what I'm about to say about t's. If I said, find the equation of the line that goes from negative 1, 5 to 2, 3, what would you do? Find a slope? Don't have a y-intercept.
Oh, wait, no.
Alright. What 2 things do I need for the equation of a line? Slope? Point. If it's a y-intercept, that's awesome, because then I know what b is. Do I have a way to get the slope? Yes. And by the way, I really want you to understand, I'm not answering the question yet. I've changed the question, just to make sure you all know what to do. If the question had been, find the equation of the line that goes from negative 1, 5 to 2, 3, that goes through those 2 points, then you would have done, find a slope, y2 minus y1, blah, blah, blah. You could plug that into y minus y1 equals mx minus x1, or you could plug it into mx plus b and solve for b, correct? Is everybody with me? Then you would get y as a function of x. You would get y equals mx plus b, correct? Everybody with me? Okay. Gotta pretend like everybody's with me. What's the idea with parametric? In a parametric system of equations, is y a function of x or x a function of y directly? No. What is x a function of? T. Kick ass. So if I have y as a function of x, I need 2 points xy, xy, correct? Everybody with me? If I give you 2 points xy, xy, and I say find the equation of line, you should all go, thank the gods, Jeff was feeling in a good mood when he made this problem. I'm going to eat this problem up. You're going to give me more of that problem, Jeff. Everybody should be saying that right now. This problem is talking about parametric equations. What did you just tell me? X is a function of t. So I need 2 points. Tx, tx. What's the first value of t? First value of t.
0.
And when t is 0, what is x? But isn't that a point? 0, negative 1. Yes? So if I am trying to figure out the parametric equations, I need x of t, and I need y of t. What do we know for x of t? I know when t is 0, x is, what was it, negative 1. And I know when t is, what's the other value? 1, x is 2. And I'm going to work towards getting x equals mt plus b. The letters don't mean shit. Y equals mx plus b. A equals mh plus b. W equals mf plus b. Who gives a shit? So how do we get y equals mx plus b? I need 2 xy points. How do we get x equal mt plus b? I need 2 tx points. Can you get the slope? What kicks ass about this point? The x-intercept. Sorry. It's the whatever the shit this is intercept, yes? So, and then y of t, is everybody sort of with me? I need you to understand. Y is a function of x. 2 points, x, y, slope, blah, 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 solve for b, bullshit, yes? If I need x as a function of t, I need tx, tx. Slope, solve for b, blah, blah, yep, all the same shit. What about y? Y is a function of t, so don't need 2 points. When t is 0, y is 5. When t is 1, y is 3. 2 separate problems. So why do I love this? Because in a parametric system of equations, x and y are independent until you kind of connect them through t. So look, aren't I doing independent work? This is its own problem. This is its own problem. Because x does not directly relate to y in a system of parametric equations. They both relate to t. They are not primarily related to each other. One of the funkiest problems in the whole homework, for sure. And that's all I'm going to say. Okay. So the main thing with parametric equations, x is a function of t, y is a function of t. So everything we've done before with y as a function of x, we do the same shit, but just with x and t and y and t. Okay. What else we got? That's a good question. Hopefully that helped. I mean, I ended up doing most of the work like I almost always do, but hopefully that makes sense. Okay. Anything else?
So, would you set up the slope with t? So, like,
How do you get the slope?
well, it's
This minus this divided by this minus this.
okay. So you do use.
That's the slope, yeah? So all the work is the same. It's just that in this case, this is t, this is x. And in this case, this is t, this is y.
Yeah, that's what I'm confused about. T doesn't actually show up on the graph.
Oh, the graph, no.
So how would you plot? Like, how do you make the slope if there's no rise over run? Because t isn't.
So, look at here. Right down here, right below, right here. Does x have a linear relationship with t in that problem? In this problem right there. Let me pull it up here. Does x have a linear relationship with t? Does x have a linear relationship with t?
Yeah.
How do you know it's linear?
The first power.
Yeah, all the variables are to the first power, correct? What's the slope of the xt line? On the graph, will a slope of 1 have anything to do with anything I see directly on the graph? Nope. In constructing my x parts of the points, will the slope of 1 mean something? Hell yeah, because that's how it's controlled. So you're right. The work we're doing won't show up on the graph. What'll show up on the graph are the output x's and the output y's put together. So the t is behind the scenes making the x's and making the y's, and we put those together and plot them. And that's why we get so funky equations, because now I have a lot more flexibility than I did before. Funky graphs, I should say. Okay. It was a good question, though. I love it. But so any work you do with t will not directly show up with the graph, because like you said, I don't see a t-axis. T is wait some time. Wait. There's the t-axis, is me waiting. Me waiting is the t-axis. That is so weird. Maybe. But that's life. Throw the ball. Wait. Oh, there it is. Wait. Okay. You can argue that the only reason the ball moves is because there is a t-axis. Time is moving. Okay. We won't get into any trippy quantum mechanics, don't worry. Okay. Now, again, it's okay if it doesn't make the most immediate sense, because it is trippy. And we don't live with this shit very much. You don't immerse yourself in parametric, right? We did it relatively quickly. So that problem was on the edges of the extent to what I thought you could maybe handle on your own, but it's weird. So, okay. Where did I leave off? Let me make sure everybody got their stuff back. Alberto. Let's see who else didn't get theirs back. So you can see the distribution up here, and I had a quick discussion earlier about, if you paid attention to anything I've ever said about the spread, that number should kind of stand out. So I had some 101s, and then I had some people in the 20s, so it was a very wide spread. And if you are down in this area, figure out if it's easy to explain. If you didn't do much of the homework, that's easy to explain, right? If you didn't study at all beyond the homework you did, it's easy to explain. So that means it's in your control. If you ever get a low grade and you feel like you did everything you could to get ready, come see me. Well, come see me either way, but we'll have to figure that out. That's where my job becomes more of a private investigator, looking into your math habits to see what's going on. So any questions from the quiz before we, any more questions from the homework or the quiz? Yep. Okay, so I think everybody basically you all had almost the same problem, but it's a little bit turned around. So let me do one like it. Do I want to set this up? No, I think I told you guys I got my pencil back. But now I kind of don't want to use it. I'll get back to it. Maybe I should use it. Yeah, I'll use it. All right, let me see. It just takes a second to set it up, so it's a little annoying. Wake up. Dadgummit. I love it. Stop it. Clear. There. What is all this shit? Okay, here we go. Oh, cool. That's already there. 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 Oh, yeah, thank you. Oh, do you need a...
Yeah, let's do
that. Okay, let's see if Jeff remembers how to do any of this stuff. Obviously not. Where'd it go? Oh, this way, Jeff. Is it over here? Yes. Look at that. Holy jeez. Okay. I got it. Okay. So I gave everybody a point that was in rectangular coordinates. So you all had something. I don't want to do them. All right. So let's just say I gave you like this. Yeah. Huh?
On the board.
Oh yeah, thank you. I appreciate your patience with me, with multimedia shit. Oh. So what do I need to do to turn this into polar? What two things do I need to figure out? R and theta. How do you figure out R? What's true? R squared.
X squared plus y squared.
X squared plus y squared. So here's one little thing that happened. Well, no, I'll get to there. When you square both, they're both positive, correct?
Yeah.
Negative 4 squared is not negative 16, so you don't get R is 0. That wouldn't make any sense. So you get 16 plus 16, so you get R is the square root of 32, which is square root of 16 times 2, so 4 squared to 2. All right, let me stop for a minute. Is everybody with me? I think most everybody got R. Okay. It was theta that was the issue. Of course, the one I gave you was a little bit weirder, but first thing, right now, can anybody tell me what quadrant we're in? Yeah, negative 4, 4. So I'm in the second quadrant, correct? Keep that in mind, because whatever angle you get, it better frickin' be in the second quadrant, or you're not representing that point. It would be impossible to represent that point if you don't end up in the second quadrant, because that point's in the second quadrant. So you got to realize that's quadrant 2. Oh, I've got it set to something weird. Sorry. Thank you for putting up with me. All right, I'm going to leave that. This is quadrant 2. Now get out of here. That's better. Don't correct my horrible writing. Oh, that's my R's looking at that. Oh, that's so trippy. Okay, sorry. Thank you, guys. It's like low poly stuff. I'm in quadrant 2. How do I figure out theta? What's got to be true about theta?
Tangent theta equals y over x.
Y over x, which is negative 1. I'm almost always, for most of the problems I give you, I'm going to give you stuff you should know. In fact, on the quiz, I said use exact values, and some of you guys gave me silly decimals. That's not good. That's not exact. If you want to give me a decimal exact, you should still be writing it, correct? I need more paper! Putting, okay, you guys know? So when is tangent equal to negative 1 in the second quadrant?
Or 3 pi.
In the second quadrant? 3 pi over 4. So for most of the time, you don't have to do inverse tangent. Most of the time I'm going to give you a value you should know, then you can be kind of smart about it and go, I know I'm supposed to be in the second quadrant. Tangent's 1 at 45-degree angles, pi over 4, so I have 3 pi over 4 in the second quadrant. So what's my point? Do I have one? Thank you. 4 and 2. 3 pi over 4. Cool. Is that all right? So everybody here, you had a rad 3 or a 1 over rad 3. I think they were negative, whatever. Here's, again, let me help you guys out. Tangent goes like sine. So when will tangent be rad 3? That's the bigger one. When is sine bigger? 60 degrees. That's pi over 3. When will tangent be rad 3 over 3? That's the smaller one. When is sine smaller? 30 degrees. Some kind of pi over 6 referencing. No? Yes? Trying to help you guys because you have to have this stuff memorized. I don't have tangent directly memorized. I do that. Tangent goes like sine. When is sine bigger? That's 60 degrees. Oh, okay. Maybe. Maybe not. Okay. Some of you guys are like, I hope this is not that big of a part of the class. Maybe I can pass. No. Memorize your shit. All right. Anything else from the quiz or homework? Okay. Some of you guys, I don't know, on number 3, some of you guys just left parts of it completely undone. So I put in bold to really highlight what it was I was asking you to do. And some of you guys, I don't know if you didn't know how to do it. Hopefully nobody just missed it. And you're like, I could have done that.
That was me.
Oh man, I'm sorry, Danny.
Completely missed it.
But just, read the whole thing. Okay. So if there's no questions, we're going to get back into doing more examples of what we did yesterday. And then I'm going to talk a little bit about some of the sections that are extra credit. And then I have the practice test to give you guys. So let's do this. Let's real quick. You guys are going to help me. We're going to set up a problem where we know the answer going in. And then we're going to calculate the answer. So you guys are going to help me. We're all going to be teachers right now, right? So automatically your pay is going to go down. I'm sorry. So what does an answer to a 3-variable system of equations look like?
That's
X, Y, Z. Looks like a 3-dimensional point. X, Y, Z. So just like in 2 dimensions, the answer is the point that they meet, the 2 lines, the point that the 2 lines meet. In 3 dimensions, it's the 3-dimensional point where the 3 planes meet. And I was talking about parts of the room. Yes? Okay. So, can somebody give me reasonable numbers? Somebody give me what the X would be. Let's construct your answer first. We're teachers. What do you want the answer to be? What X value? Give me a number. Give me a number? 7. We're off to the start. Now, somebody else. What do you want the answer for Y to be? It could be negative. Don't make it like 87,000 or something stupid. Don't make it square root of 11. Make it something nice. 5. Okay, now somebody else give me a negative answer for Z. Negative 3, there we go. See, I mean, that's the time to just shout some shit out. Can't go wrong. It's just a number I need from you. Okay. So, help me out. So, this is not the way it's going to work for you, yes? At the moment, we're a teacher. We know what the answer is going to be. The answer is going to be this. And then I make a problem that has that answer. Now, very quickly, this ain't what happens in real life. In real life, we make observations, we set up equations according to our observations. If there's 3 variables, I need 3 distinct observations. I set up equations for all of them, and then I can solve. Here, this is contrived. That's why I love the thing about only in math can you buy 60 cantaloupes and nobody wonders what the hell's wrong with you. Because a lot of the frickin' word problems are so contrived. Okay, I really just want to make sure you guys are with me. So watch this. Let's make the first equation something very, very, very simple. What is x plus y plus z?
Nine.
Yeah, so 12 minus 3, 9. So now let's do negative 2x plus 3y minus z.
Four.
Yeah, I got 4 also. Does everybody understand what's happening right now? This would be negative 2 times 7, negative 14, plus 3 times 5, 15. Negative 14 plus 15 is 1, minus z, minus negative 3, plus 3, 1 plus 3 is 4. Is everybody really with me? So this shit is easy if I know the answer, of course. Just making, now, whatever the numbers are, I'm just making the equations that actually work with those numbers. So here, you guys help me make the last equation. Give me a coefficient. Huh? 20?
Yeah.
Jack loves us all. 20x. Give me a negative number in the teens.
Negative 17.
Negative 17z. Now give me a nice 1 to 10. Why did I put a z there? I'm awesome. Make that a y. Which one was my eraser? Yeah, that's my ruler. Oh shit, Jeff, you're out of. You were as if you were ever. Okay, there we go. That's a y there. Sorry, guys. And then you said 1. Okay, so you guys, what would that be, Jack? What's that, Mr. 20?
52.
Oh, 56.
56?
Not 56, sorry, 52.
52? That's what I got. Is that all right? 140 minus 85, that's 55 minus 3, 52. Okay. So you're not going to get this, obviously. You're going to get this. This will be what I give you as a problem, and I would already know what the answer is because I'm special. I'm the teacher. It's good to be the teacher. Now, what is our goal in these problems? Sure, but in order to get there, what's my goal right now? What sucks about each of these equations? There's 3 variables. If y and z weren't in the first equation, that would kick ass. X equals 9. That would be the best equation ever because I know what the hell x is. Too many freaking variables in my way. So what's my primary purpose at first? Kill a variable. Which variable is easiest to kill? Z. I love it. So not always will this happen, but almost always there will be 1 or 2 variables that are easier to kill than the third one. I could kill x. I could double the first one, add it to the second one. I can multiply the second one by 10 and add it to the. You guys with me? But why is z so much easier? What's one way to kill z?
Add the first and second.
Yeah. Add the first and second equations. And that's going to equal 4, of course. Our fourth equation, yes? What's the first plus the second?
X plus 4.
No.
Negative x.
Yep, negative x. Oh, this, by the way, guys, dear guys, well, so I'm adding the first and second equations, yes? So I get x plus negative 2x plus negative x, yes?
Oh,
Okay. And trust me, one negative mistake, the whole thing goes to shit. Because everything is interrelated. So please understand, as long as you show me you know the process, If you make a little mistake, everything's going to go to shit. You're going to get some funky ass answers. Do not erase everything. I'm going to give you a bulk of the points if you can show me you understand the process. We are only human. We're going to make a negative mistake. And the minute I do, the whole thing's dead. You guys with me? The minute I can make a negative mistake, there's no chance. There's no chance in hell. And more than likely, I'm going to get answers like 17 over 533. Like, what the shit is that? And then people put a little, why'd you make it so hard? I'm like, no, I didn't. You made a mistake. It's okay. We're human. So don't erase your work. Show me you know the process. So keep going. X minus 2x is negative x. Y plus 3y, 4y.
Equals 13.
Yeah, and the z's cancel, yes? Equals 13. Is that fourth equation better than the 3 I have already? Yes. So I have 4 equations now, yes? And one of them is the best. Why is the fourth equation the best so far? It's only got 2 unknowns. That's always better than 3 unknowns. What do I do next? We kill the variable. Good, because the whole problem at the beginning was there's too many damn variables, so we killed one. Kill it again. Yeah. Sorry. This is math lessons, not life lessons. So what's the easy way to kill it one more time? Add 2 and 3. Could I not also, and we're not going to because you didn't say so, couldn't I do 3 minus 1? Couldn't I, or I could multiply 1 by negative 1 and add it to 3? Is that so there are multiple ways to do these things. But the easiest, most direct way is to take 2 and add it to 3, because then the z's, look at me pointing at, I love it. Do I have a laser on this one? I think I found it before, but I'm not going to look for it. Is that the laser? No. That's just the color jump. Ooh, look for smart person. What is that? Okay, sorry. It's been a while. I forgot everything already. 2 plus 3 is 5. That works this time. So when I add those 2 equations together, 2 and 3, what do I get? Yeah, I get 18x minus 14y equals, and the z's cancel. 56. Now, real quick, those 3 equations are still true. They still live. They still exist. We just made 2 better equations. Why do I not want to forget about those 3 equations? Because they have information about z. I've made 2 better equations, but they suck in a way because they don't have z anymore. Does anyone see something I could do with one of the equations immediately? What sucks about the 5th equation? The numbers are big. Well, can I do something? Yeah. So let's take 5 and divide by 2. Is that okay? Now, what can I do with the 4th equation so that it'll actually cancel something? Yeah, you guys, again, I need to find my laser. Just do this, Jeff. It's amazing. If I multiply by 9 and add these together, the x's cancel. So again, there I go killing again. You gotta kill a letter twice, and then you kill another letter. Okay. So if I multiply 4 times 9, I'll get negative 9x. Keep going. Plus 36y. 117. 9 times 13 is 10 times 13 minus 13. So you get 10 13s minus the 13 is 9 13s. Or you got a calculator, right? All right, let's add these together and see if we've made a good system of equations. I don't know. Was that 89? Does that work? Oh shit, we might have messed up somewhere. Let's see. That's going to suck a lot. Double check what we started. That's true. I might have done something wrong in my head just now, so you guys try to keep going. Yep. 140 minus 85 is 55 minus 52. So those look good. So that's not a mistake. What do you guys get here? Did you get 29y equals, oh, I subtracted. Why did I do that? We're probably fine.
It works.
Yeah, so this would be 145, is that cool? I subtracted for some reason. So then y equals 5. And by the way, what did we want? What did we make y equal to in the first place? 5. Okay, so one reason I like to do this, because you guys are never going to do this. You're never going to start with the answer. But I like to show you, we constructed this equation based on the answers. So of course, if I solve it, I better get the answers I started with, or else this whole thing is shit. We can throw it out and go home. Unfortunately, we got 5, so we can't throw it out and go home. Too bad. Where do I go from here? Where do I go? Yeah. So yeah, equation 4 is a nice equation. It's better than 5 because it's got smaller numbers. It doesn't matter which one you plug it into because it's all supposed to agree anyway. So if I know y, I can do dominoes. I can fall back, and now I can use this equation to figure out what x is. So go ahead and do that. I'll wait. Don't say anything. It's not going to be a surprise, but still, it's good to see it happen. Here I go again. Oh, here it is. Does anyone need the handout that is an example of this kind of a problem? Everybody else is good? So while you're doing your homework, it's good to have the sucker sit next to you. If you want to. You can do silly things if you want to. So what do you guys get? So negative x plus 4y equals 13. You get negative x equals negative 7, right? So you get x is 7. Holy shit, x is 7. And now what do I do to get, am I done?
No.
I've done a lot of work. I'm not done yet. Damn it.
Plug them into number 1.
Now I know x, I know y. Now I got to go back to the original equation. Now all of a sudden, these are the best equations because they're the ones that have z in them. None of these are bad because they all only have one unknown, z. So it doesn't matter which one you pick, but obviously I'm going to pick the first one because it's the one with the best coefficients, yes? So it would be 7 plus 5 plus z equals 9. 7 plus 5 is 12. Subtract it from 9 and get negative 3 is not, again, not a surprise. You guys all with me? A little bit? A little tiny bit? Okay. So, I'm going to go ahead and, yeah, sure. No, let's do one like this. So what if I gave you this system of equations? A plus 2b equals, oh shit, now I gotta keep it in my head. Okay. 7. 2a minus c is 1. And b plus 4c is something. 7. Let me make sure. Okay. What's trippy about this? How many unknowns are there?
3.
What's trippy about this, though?
They're not all in one equation.
Not all equations have all variables, right? So in a sense, that's great. Because what's the first thing we have to do normally is kill some stuff. And somebody's already killed some stuff. Did they kill it in a smart way, though? Does any of these go together? Do any of these equations go together? Do you see what I mean by that? So the first one has A and B in it. Any other ones? No. A and C, B and C. Shit. None of them go together. Do you guys see what I mean? So the one we just did, we were smart. Look at us go. We made 2 equations that had X and Y in them that go together. Whoever the shit did this problem, and maybe it was nobody. Maybe it's just the way it is. But whoever started working on this, you're like, what the hell are you doing? So what do I do?
Combine two equations,
Okay, in what way?
like, do,
Like you solve, I mean, you set it equal to solve for C and you plug in C.
Beautiful. All right. This has A and B in it.
Or
Yes? This has B and C in it. Doesn't this one have a relationship between A and C? I really want you guys to see this. So can you guys, I'm going to number these. And dear God, it's a really good idea for you to do that. For yourself and for the poor fools trying to grade your stuff. Can everybody solve 2 for C? I think that's what you're saying, Jack, right? Okay. Everybody take number 2. Solve it for C. I'll stand here. Sorry, I'm just laughing at myself. I got a song in my head just blaring. Here I go. Okay. So number 2. What do you get when you solve for C? 2A minus 1. So now I know that's true. I know this much is true. God damn, it's just music all the time. C is 2A minus 1. I know that's a fact. I really want this to make nothing but sense. Don't memorize the process. Go, why the shit does that make sense? Can't I rewrite 3 now so that it has B and A in it? Because what can I replace in number 3? Let me change the colors.
C.
Jeff is using like 2 colors. Watch out. So I know B plus 4 times C in C is 2A minus 1. So if I mess with that a little bit, don't I get 8A? See if you guys are cool with this. 8A, right? Plus B. This would be minus 4, so I'm going to add 4 to both sides. Is that okay? I'm just trying to write less. I get 8A plus B minus 4, add 4 to both sides. I get 11, yeah.
Can't you then set it equal to B? Well,
You don't want to go, you would kind of like pass yourself in the night. Be careful. Do I have another equation that's got A and B in it? Yeah, the first one. So let's bring the first one down here. A plus 2B equals 7, yes? I think that's what it was, yes. Do you understand what just happened? So in general, you try to kill a letter twice. Because then you're left with 2 equations with the same 2 letters, kick ass. If the problem starts with some letters missing already, you might have to do what we just did. Solve for a letter, plug it into somebody else, and what's the real goal then? I want 2 equations with the same 2 unknowns. How do you normally get that? Kill a letter twice. How do you sometimes have to get it? Be creative. Gotta think creatively. And now, what do I do? I don't know. Yeah, there's 2 ways to do this. So if you multiply the third equation by, well, how can I kill the b's? Multiply this by -2, yeah. -2 times this. So again, -16a minus 2b equals -22. The most common mistake is to forget to multiply this side of things. Okay. So now if I add those together, what do I get? -15a. The b's by design die. So I get a is 1. Are you guys semi with me? Are you guys kind of with me? So on one level, this should be awesome. We're just solving really basic equations. They're not square. These are all linear. Every variable is to the first power. On the other hand, you do have to be a little creative about how you make things cancel, how you make things have the same variable as somebody else, all that kind of stuff. It's a little bit of creativity. What can I get from this? I know A is 1. Can't I get B and C now? Isn't C twice A minus 1? So C would be 2 minus 1? Look at Jeff. Look at Jeff making a problem in his head that he could do. And then I'm golden. How do I get what do I have left? B. I have several ways to get B. So if I just go back up to here, A plus 2B is 7, 2B is 6, so B is 3. Crazy shit. So it wasn't 1, 1, 1. Get off my case. Can somebody, now listen, as long as you circle your answers, what answer did I not circle? A, oh right here. C, B. I'm fine, but can somebody tell me what that would look like as a point? 1, 3, 1, good. So if I don't say otherwise, points are always in alphabetical order. So A, B, C. So 1, 3, 1. That is the point that those 3 planes would intersect at. That's like that corner right there. Okay, maybe. And the book's got some good drawings. I mean, I'm not going to try to draw 3-dimensional planes. I can barely handle 2 dimensions, okay? But this is, I can use physical planes in the real world and just point to a thing. And the book has, computer-generated images, so you can look at those. Okay. You guys, I mean, relative to some stuff we've done this semester, it's kind of funny that, I hope you agree with me, Chapter 11 so far has some of the easiest problems. I hope you guys agree that these are not difficult compared to some other stuff we've done, for sure. Now, I'm not trying to make you feel bad if you have some trouble with these, because some of them can get tricky, but the math involved is very low level. It's just you got to be careful about how to manipulate things so you get the variables. Okay. Yeah, let's do this. I want to talk a little bit about section 10.8. I made that extra credit, if I remember correctly. Was it 10.8? Yeah, okay. That had to do with something called vectors, so I'm going to just talk about this a little bit, and then I'm going to give you guys the practice test so we can start looking at some of that. We get a little early start on review for the test. Vectors. So, let me see. Shoot. If I say vector, what comes to mind? Does anybody have anything come to mind when I say vector? Isn't that the name of some
Location.
villain? Huh?
Like a location of.
I'm gonna Google, okay?
Direction and magnitude.
Okay. Google it.
Direction and
I like it.
magnitude.
Say again? Sorry?
Direction and magnitude.
Alright, direction and magnitude, I love it.
That's what it
Anything else come to anybody else? No, I don't need to see. No. You see, this is the one I want. Yes. Alright, so here is a wonderful, let's zoom in on us. It's a wonderful. This is a absolutely beautiful, it's not quite a vector because they're curving, but you can have things described by vectors that curve, but anyway. Vectors are normally considered to be these straight lines. This is a wind map. Where is the wind strongest? Where the lines are
Mostly condensed.
The lines are brighter.
not really bright. They're brighter here because there's a lot of them. Let me see if you guys look. Can you see the wind
Or it's
here?
moving quicker.
Look at this wind. Look at that little wind right there. Look at him. Ooh, I can even look at that shit. I didn't. Wow. Damn. How long is that vector compared to the vectors over here? How long is this? I don't know if you guys can see. You guys might not be able to see. It's actually a decent little wind map. All right, let me zoom in. Oh, this is trippy. All right. See these guys here? Look at this little guy. See this guy? Yeah, I'm smushing their town. Okay. The length here compared to the length of like these. Which one's longer? These. The length of a vector directly relates to its strength. It's something we call the magnitude. So the vector represents wind. that would relate to this wind velocity. The longer the vector, the stronger it is. Now, if I have a lot of them together, that just means that there's wind going in one direction in that area. So this looks like, so if these were shorter, it would be weaker wind, just consistent wind over a large area. I don't know if you guys are, I'm not going to get into meteorology. Oh my God. You guys get this idea? A vector's length directly relates to whatever physical quantity it's measuring, I have more of that. So if my vector represents force, this is not much force. This is quite a bit more force. Yes? It's like me pushing like, or me pushing like, my vector for the second will be much bigger. What else is true about vectors? What's another thing that I'm curious about with wind? Not just how strong it is,
Direction.
what direction it's blowing, because that could determine how we're going to approach the runway, if I'm in a plane or whatever. Yes? Okay. So vectors have two components. Their length, which we call magnitude, and their direction, which are determined by an angle. You guys kind of with me? So like if any of these are blowing straight this way, I could think of that as being 180 degrees. Because do you guys see what I'm saying? Yes. If anything's blowing straight that way, that's 0 degrees. Straight that way, that's 90 degrees, or pi over 2. You guys kind of with me? So there's going to be a magnitude, a length, this is another name for that, and a direction. So we've done this shit. We've done this before. Not the wind stuff. So let me give you an example. If I really hope this not like no. I want to say this. Yeah. Jeff, good Lord in the half, dude. You have a grid paper, my friend. Okay. It's amazing. Okay, right. This is a vector. It's got direction and it's got length. But haven't we looked at this kind of thing before? What are the coordinates of its terminal point? What's the coordinates of where it kind of stops? 3, 2. So here's the thing. I made vectors extra credit, but almost all of the math is math you've done before. How do I figure out how long it is? The magnitude of the vector. The length. And how do I figure that out? Pythagorean theorem. Yeah, it's just r squared equals x squared plus y squared, right? Okay. So what's the length of this vector? Let me give it a little terminology. I'm not going to get too deep into this, but very often we call a vector, some of them, like we use x and y for numbers. For vectors, we use u and v very often. So this is vector u, and it has a little arrow on top to signify it's a vector. Looks like a V that kind of like fell over. You could think of it that way. So that symbol just means that's the U vector. Because then I can have another vector that would be the V vector, whatever. Yeah, okay. So the symbol we use, so real quick, can you guys tell me, this would be the square root of
13.
what?
13.
Yeah, 3 squared plus 2 squared, 9 plus 4, 13, yes. The symbol I would use for this should also look familiar. Is that. Remember what those meant? Those, we kind of called them absolute value until we learned really it's the magnitude, it's the length, how long that thing is, yes? So there you go, it's the same thing. The magnitude is the length of the vector, is what we've done before. It's just x squared plus y squared square root. We've done that stuff before. How do I figure out the direction it's going in? Yeah, how do we get it? Inverse tangent of y over x. 2 over 3. And then you throw in the old calculator, whatever the hell you get out. So a lot of the only new, well, let me be careful. There are a few new things. But the main new thing with 10.8 is just the notation. Right? I can have vector U, I get the little symbol on top, vector V, I get the little symbol on top. I can have vector A, B, and C with little symbols on top, right? How much more do I want to do this? So what if I told you, no, I don't want to do it. That's enough. I don't want to talk too much about it. That's extra credit, so I'll let you guys get in there. But that's the basics. The math you use in section 10.8 is the same math we've done before. So that's why I figured if I make an extra credit, you guys have a good attempt at doing that homework because it's all the same math we've done before. So let me do this. Let me give you guys the practice test, and then I'm going to let you kind of like scan through it and see if there's anything you want to talk about today. And the rest we can do tomorrow. Anytime. So I start us off with the most recent stuff, just because. Oh, Jeff, you should probably turn this. Today's lesson brought to you by Lumens. Okay. And the Optometrist of America. All right. So it's kind of funny, the instructions I gave you in the first place, solve the following by hand. We haven't learned this yet, but when we get further into chapter 11, there's actually a way to solve those equations using the calculator. Now, if you think about that for a second, that should seem really strange. But there is a main thing in our future. Let me just say one word. This is not on the next test. It's after the next test. We're going to talk about matrices. Right? The matrix. Right? Not, there is no spoon, but mathematical object that helps us do things like this very easy. Can you imagine, is it like number B, number 1B? That's going to take a little while to do. Do you guys agree? Because you got to kill a letter twice, and you got to kill a letter again, and you got to back, so it's just going to take a while. So I'm not going to give you like 8 of those on the test, maybe 7. What if I added one more variable? If I add one more unknown, what else do I need to add?
Another 3 times.
No. How many equations do I have
2.
in part B? 3. And how many unknowns do I have? 3. The only way I could have a chance to solve a system of equations is if the amount of information I'm given is equal to the amount of things I don't know. Now, on one level, it kind of makes sense, hopefully. So if I add like a W vector, W variable in, don't I have to give you one more equation? You guys with me? Can you start, I think I talked about this yesterday a little bit, can you imagine how much more work that's going to be? I got to kill a letter 3 times, and then amongst the survivors, I have to kill a letter twice, and holy shit. Now, consider me adding 7 more variables. 7 more variables. How many equations do I have to give you then? 7 more, so I have to give you 10 by hand. How long would that take? I don't want to think about it, Jeff, because I would never do that shit. You give me that problem, I'm saying, screw you, man. Yes? And I don't blame you. If I gave you the problem, you should say, screw you, man. The process we're going to learn with matrices, when I add more stuff, the amount of time it takes to do it is minimally more. It's a very powerful method. So we're going to learn that later. So all I'm going to give you on this test are at most 3 equations with 3 unknowns. You guys with me? So obviously I wanted to get you ready for part C. So earlier today we did an example like part C. Which variable in part C is easiest to solve for? Z, totally, because every other variable I have to create variables, to create fractions to solve for them. So I would rather solve for Z because it doesn't have a coefficient. I'm not going to make fractions I have to deal with. You guys with me? So we did an example like that earlier. Part B is just your normal straight up kill, kill, kill. Yes. All right, so look through the rest of it. I'm sorry, just want to point a few things out. Look over the rest of it, and if you see anything you have an immediate question about, we can look at it a little bit closer. If you see one that you want to do more examples of, let me know. Yes. Oh, I'm sorry, Colin. I'll get back to you. Yeah.
2A.
Oh, yeah. Okay. So what do I mean by the complex plane? What does that mean?
Why is imaginary?
I love it. That's it. Here's the real numbers. Here's the imaginary numbers. Yes. Let me ask you this. What's A? In part A, what's A? 3 rad 3. What's B? Negative 9. Good. Not negative 9I. A and B are the coefficients. So if I want to graph this thing, graphing 3 rad 3 is not the easiest thing in the world, but what is 3 times rad 3? Just do it in your calculator and give me an approximation, yes? So here's my real axis, here's my imaginary axis. So how far on the real axis am I going to go? What's 3 times the square root of 3? It's like 5.13. I just made the last part up. 5 point what? 2? Okay, I can live with that. So 1, 2, 3, 4, 5. So 5.2, and how far am I going to go on the imaginary axis? Yeah, negative 3, negative 6, negative 9. So 5.2,
That's 4.
negative 9.
That's 4.
Oops, 5.2, negative 9. Thank you. So to graph a complex number, what we used to call the x-axis is the real part, and then the y-axis direction is the imaginary part. That's it. The reason I want to make you graph these is because now I know a couple things. I know what quadrant I'm in. Yes? I know which direction I'm facing. I know all kinds of stuff. So how do I write this in polar form? What does it look like in polar form in general? So do you agree with me that a complex number is basically the x is the real and the y is the imaginary?
Yes.
All right, so in polar form, what is x? Or cosine theta, what's y? Or sine theta. And then if I take an r out, I get this.
You can't see it.
Does that look familiar?
Yeah.
So do you have to memorize that? Not really. You can kind of create it as you need it, or you can memorize it, either way. It's r times cosine theta plus I sine theta. And I really want to wrap this all up for you. So, real quick, isn't the real part of this the amount that lies in the x direction? Yes?
Yeah.
Wouldn't that be r times cosine theta? So that's all this says. The real part would be r times cosine theta. And the imaginary part would be r times sine theta. That's all. So, how do I get r? How do you always get r? X versus y squared square root, yes? In general, r can be negative. When we're doing complex to polar, we normally pick r to be positive. So help me out. Square root of what? 3 rad 3 squared plus negative 9 squared. Don't put the I in there. So in the homework, some of you guys were putting the I in there, and it was made some weird ass square root of negative stuff for the radius. That's weird. Now, there was a problem on the quiz where you had to do something like 3 rad 3 squared. What am I squaring in this first piece? What am I squaring in this first piece exactly? I'm squaring the 3 and rad 3. What is 3 squared? 9. And what's rad 3 squared? 3. So that's 27, yes? And of course, yeah. So it's 27 plus 81, 108. And then, you're like, it never ends. Real quick. Do you guys know how to tell if a number is divisible by 9?
Yeah.
If you add up all the digits and they're a multiple of 9, the whole thing is divisible by 9? What's 6 plus 9 plus 3? 18. So 693 is divisible by 9 because when you add up the digits, it's a multiple of 9. Did anyone, I think I said that before to you guys, but I can't remember. Has anyone ever heard that before?
It's the same with threes, right?
3, same kind of rule. If you add up all the digits and it's a multiple of 3, 3 goes into it. Now, real quick, how do I tell if 4 goes into something? Does 4 go into 100? Total. 4 quarters makes 100 cents, yes? So 4 times 25 is 100. Therefore, 4 goes into 104. 4 goes into 108. 4 goes into 200. 4 goes into 244. 4 goes into any freaking number where the last 2 digits are divisible by 4. So it doesn't go into 1,975,344. Yes, because the last 2 digits are divisible by 4. Again, not in our curriculum, but it's just good shit to know. We made up the numbers. All of us humans should know all this shit. What does that have to do with anything, dear God, Jeff? Well, when I have a square root, I have to see if I can reduce it. Didn't we just say that 4 goes into that? 4 quarters is 100, so 4 times 25 is 100, so 4 times 27, 2 more 4s is 108. So this is 4 times 27. And what's 27?
9 times 3.
9 times 3. So isn't this 36 times 3? Square root of 36. 6 square root of 3? I don't know. So there's R. Now if you just stop at square root of 108, I don't know. I'll take off at most a point. But you should just take a moment and see if you can reduce it. Simplify it. I like to call it reducing because it's sort of like the same feel as reducing a fraction. Okay. So we got R. I still need theta. So of course, how do we get theta? Yeah, inverse tangent of, I'm just going to write tangent theta equals y over x. If I reduce that, I get negative 3 over rad 3, and if I keep going, I get negative rad 3. 3 divided by half of 3 multiplicatively is the other half of 3. Or rationalize the damn thing and you'll get to that. And I told you guys earlier, now real quick, what quadrant are we in? We graphed it so we know. What quadrant are we in? 4th quadrant. My angle thing could be negative something. When is tangent rad 3? Tangent goes like sine. Rad 3 is the bigger possibility for tangent. When is sine big? Pi over 3. So negative pi over 3. That's what theta is. So whenever I'm dealing with polar forms of anything, I need to know what quadrant the thing I'm talking about is in. That tells me what the angle is going to be. Because when I do inverse trig stuff, it just gives me maybe a reference angle. Maybe. And now you're all sitting there going, that was one problem. I kind of went slowly through it, so you know. So you do the exact same thing with part B. What's different about part C? There's no real, yeah. So real quick, z equals negative 2i. Where's that? Straight down. So how long is this? Do you have to do any work? How long is it from 0 to negative 2 on the y-axis? 2! R is 2. And what angle is that?
3 pi half.
Yeah, 3 pi over 2 or negative pi over 2, whichever way. Are you guys all with me? That one's nice. You got no real work to do because it's on an axis. That kicks ass. The only time the length is easy is if it's straight across, yeah? If it's diagonal, shit. If it's straight up, down, or straight over, kick ass. That's why the absolute value of negative 7, we didn't even talk about that being like a magnitude of a vector or whatever the shit, because it's just 7. Because it's on a straight line. It's not diagonal. The minute I get some diagonal shit going on, oh, old Greek dude says, I got you. But he says it in Greek. And I don't know how to say that in Greek. Okay, so. Let's see. This kind of problem, you should just, eat that up. Does anyone ever see anything interesting about any of these points? Yeah, dude. What's going on with that last point? God damn you, Jeff. Can't you just let anything be easy?
Larger than 2 pi.
Come back. Okay.
Not a value we've memorized.
True. But that doesn't matter, because all I'm asking you to do here is plot it and give me other representations. I'm not asking you to convert it to an exact value, right? So you said something interesting, Kyler. What'd you say?
It's not bigger than 2 pi.
Yeah, so doesn't this have some rotations built in? How do I take some of those rotations away?
Subtract 2 pi.
Subtract 2 pi. What is 2 pi, what over 12? 24 pi over 12. So subtract 24 pi over 12 a few times. You'll take some of those rotations away. You'll see where you really are. Are you guys, does that make sense? Am I going to do that to you in the test? Probably. You know me. But if you get a big ass number, just go, oh shit, dude. And you just have to subtract some rotations. You got to subtract 2 pi. It's a fraction, so you need an LCD. What do you do? Just subtract 24 pi over 12 until you get until you can't. Right? So if you subtract, what's 3 24s? 72. So if I subtract 72 pi over 12, what do I end up with? 13 pi over 12. Isn't that, now that's in there. You can find 13 pi over 12, yes? All right, so that's the idea. So don't let that bother you. I'm just going to remind you, oh, you can just keep rotating. Just take some of them away. So you're like, okay. But fundamentally, these problems, this kind of problem is easy as shit, yes?
Yes.
Please do God. Okay. Especially because I'm not asking you as many million things as I did in the quiz, but up here I'm asking you to convert. How do you guys feel about that? You should feel very happy about this. Because what is x? R cosine theta. So then it's one step and you're done, basically. Yes? What about this guy? What do you wish this was? Do you want to multiply both sides by r? No, because then on the other side you have the same issue. So instead of multiplying by r to get r squared, I'm just going to square both sides. And then what's r squared? Yeah, okay. I don't know why I'm doing all this, but okay. Let's leave something for tomorrow. Anything else before we head out? Yes?
For the graph with the sign and stuff like that on the x and y, you, for the intervals, you use ranges or you use
Oh, dear God, no. Use what I would do is I would start with 0. I'd leave some room, pi over 4, pi over 2. So I go by pi over 4. And the reason I leave room is in case I'm I need more resolution. I'm not sure how it's connecting. Yes? So I would do 0, pi over 4, pi over 2, up to 2 pi. And then I'd evaluate the X piece and I'd evaluate the Y piece, yeah. And again, when you're graphing, this doesn't have to be exact. You can put a decimal. You have to put a decimal because I don't know how to graph 5 rad 3 over 2. Okay, so tomorrow, obviously, tomorrow's devoted to review. I'll have the answer key for this practice test. Every time I say that, I'm like, oh yeah, I gotta do that. So somehow I have that tomorrow. Okay.
Luckily, it was just small mistakes. I, for some reason, only squared the rad 3, so I got 10.
Oh yeah, yeah, yeah.
So then,
You were not alone. And that,
yeah, that's
that's
wrong.
much better.
Yeah,
Yeah.
and then
Make sure that ends in the
that
right
just-
place. Yes.
Alright, these are just labor calculations. And then,
I'm giving a test on December 4th at 3:30. So that's Wednesday, I think. Wednesday, December 4th. So do me a favor, double check and make sure that works. Shoot me an email so I don't forget, and I'll tell you which room we're in because I don't remember right now. It's a different class, so yeah.
I only have time, only time that